So I've just lectured you about that you need to be actively engaged while we're doing these videos. Have your calculator out, be writing these down. I hope you did that. If you haven't already got your stuff ready here, pause this video right now, okay, and have some stuff so you can participate as you go along here. Now, there's a bit of a shortcut here. To find V2. We can find V2 through the same process we just found V1. Take V dot divided by the area. The only thing that changes is this is 0.5, and do the whole thing and do your calculations. You can also do it this way. It's a little faster. Area, both of these are going to have pi over 4 in them. So this is going to be D1 squared over D2 squared, and here you wouldn't even have to convert the units. You could just say this is 0.75 squared divided by 0.5 squared times V1, and you should get the same quantity going through this same process. But notice this is the same units, so the units don't even matter here. Let's see, I've got this written down in my spreadsheet as 32.68, we'll say, 68 feet per second. There's a whole bunch more decimals there, and we don't need them. 4 significant figures throughout the calculations would be fine, because we're probably going to round to 2 or 3 at the end anyway. Okay, so that gives me both V's. Now, what the heck are we going to do from there? Well, what are we trying to do? Well, we're trying to go back up here and find the pressure. All right, so now I've got speeds. I know the Z value. I need to go find a density. Well, go in the textbook, go look up the density. And while we're there, let's go ahead and get a mu value. Normally for liquid water in English units, 62.4 pound mass per cubic feet is just fine. Just like with, in the metric units, 1,000 kilograms per meters cubed is just fine. But we've said this is liquid water at 50 degrees, so you can see properties of saturated water. I've got a row here for 50 degrees. I'm not, we can pull these values off, but you can see that's 62.4. I hope you can see it. I don't know. I didn't pull my preview up to make sure I was on the screen there. But, so I'm finding, moral of the story is you should be able to go look up properties for fluids, knowing what if it's liquid, you need to know the liquid, and you need to know, or at least make an assumption about the temperature. Well, we were given the temperature. We had water at 50 degrees Fahrenheit. So those are the things we need to know to find properties of liquids. That tells us the density in our tables, in our textbook, says it's about 62.41 pound mass for every cubic foot. And if you go look up the viscosity there, it's 8.781 pound mass per foot and also per second. And that's, sorry, that's times 10 to the minus 4. So water is going to have a very low viscosity. 8.781 times 10 to the minus 4. Sorry, I didn't leave enough room in there. I forgot it was there. But that'll give us our viscosity value. So we've got viscosity and density now for water at the given temperature. And so we should be okay now. So P1, this is a gauge pressure because we've already subtracted the atmosphere off of it. It's going to be the density, 62.41 pound mass per cubic foot, multiplied by, what do we say here, V2 squared, so it's going to be 32.68 feet per second. That's going to get squared, minus 14.52, that's also feet per second, that's going to get squared, divided by 2, and I'm just plugging stuff in this equation up here. Add to that, gravity in the English set is 32.2 feet per second squared, multiplied by Z2, we said was 20 feet. Okay, I don't think I've got this value here. Most of these values I do have. This one I do not. That's okay. So we'll run this one out real quick. Alright, so I'm going to have 62 point... No, let's do this first. Let's do the complex one here first. So let's do 32.68 squared minus 14.52 squared divided by 2 plus 32.2 times 20 multiplied by 62.41. 62.41. Okay. I hope this is right. If not, we'll redo it. I do have a final answer in PSI, but I'm not there yet. So P1 gauge is 100,266. Rounding that off. Units there, let's say I've got both of these are feet squared per second squared. That's how I can combine them. So these are all feet squared per second squared divided by cubic feet. So this would be pound mass per foot per second squared, which is not pressure by any means. That's not a unit of pressure. Am I on time? Okay, good on time. That's not pressure. To get to pressure, I need something in force per area. Well, I've got pound mass here. To get rid of pound mass, I need to multiply by a conversion factor. There's a pound force second squared for every 32.2 pound mass feet. So that'll get rid of the pound mass. That gets rid of the second squared. That leaves me with pound force per foot squared. And what I'd like to do is go ahead and go to PSI. That's pounds per square inch. So there is, for every square foot, there's going to be 144 square inches. So that should give me a number. So I should just be able to divide this by 32.2 and then divide this by 144. And I'll take that. So here I'm getting 21.62. And I'm going to write here PSIG. That's pounds per square inch. And the G signifies that that's gauge pressure. I'm going to look at my view to make sure that's on the screen. Yes, it appears to be on the screen. Okay. Now that does not match the number I got earlier, so I'm a little curious. We'll double check that, but the procedure, I'm comfortable with the procedure, even though we may have a numerical mistake somewhere. Alright, that is my current answer, temporary answer for part A. I'm going to pause here, double check my math. We'll pick up the next video. It's a nice stopping place. I'm going to pause here and double check my math and make sure I didn't make a mistake. Be right back with you guys. Loud pop.